Good morning, children. Today we'll start the fourth chapter, that is cubes and cube roots. So cubes, how to obtain the cube of a number? The cube of a number is obtained by multiplying that number 3 times with itself. For example, we need to find a cube of 2. So cube of 2, it is denoted by 2 to the power 3. So that means we need to multiply 2 3 times, that is 2 into 2 into 2, we'll get 8. So this is the cube of 8. Similarly, we are asked to find the cube of 5. So cube of 5 is written as 5 to the power 3. That means 5 into 5 into 5. So that is 125. That means 125 is a cube of 5. So here one table is given for the cubes. Similarly, in the chapter 3, as you got one table for the squares. So I asked you to remember up to 30. So here in this table of 15, in the table of cube, you must remember up to 15. That means you must remember the values of cubes up to 15. That is 15 cube. So then the next is cube roots. The cube root of a number is the number where cube is equal to the given number. The cube root of a number is that number whose cube is equal to the given number. It is denoted by in this manner. So similarly, as we have given earlier the square root sign, but here we need to write 3 since it is a cube root. Example, we are asked to find a cube root of 64. So the cube root of 64, we must think of such a number whose cube is 64. So that is 4. Since 4 into 4 into 4 is 64, therefore cube root of 64 is 4. Again, cube root of 125 is 5. Since we must think of such a number whose cube is 125, so that is 5. So since 5 into 5 into 5 is 125. Now exercise 4. Exercise 4, the question number 1, that is to find the cubes of the following numbers. Some numbers are given, so we need to find the cubes of the following. So question number 1, Roman number 1, it is given 13. So 13 cube, that means we need to multiply 13 3 times. So the answer is 2197. So similarly, we need to find a cube of minus 4 by 9. So minus 4 by 9, if we find a cube, we'll get minus 64 by 7 to 9. Again, we need to find a cube of this. That is to find a cube of 0.08. So 0.08. So if we convert it into fraction, it will be 8 whole divided by 100 cube. So if we multiply later on, we'll get 512 and whole divided by 1000000. That means 6 zeros are there. So again, when we convert this into decimal, it will become 0.000512. Question number 7, we need to find a cube of minus 2.4. So minus 2.4 whole cube. Again, if we convert this into fraction, it will be minus 24 by 10. So if that means we need to multiply minus 24 by 10 3 times. So when we multiply, we will get minus 13824 whole divided by 1000. So that is minus 13.824. So this is the answer. Then question number 2. Question number 2, it is given that which of the following numbers are perfect cubes. We need to find which of the following given numbers are perfect cubes. So the first is 64. So we already know the method of prime factorization. If we do the prime factorization of 64, it will be 2 into 2 into 2, again 2 into 2 into 2. That means these two, it forms a group of 3 numbers. Again, this forms a group of 3 numbers. So again, no other number is left out. So therefore, it is a perfect cube. So for 125, the prime factorization is 5 into 5 into 5. So these 3 numbers forms a group. Again, no other numbers is left out. So therefore, it is a perfect cube. Again, for 243, it is 3 into 3 into 3 into 3 into 3. 5 3s are there. For these 3 numbers forms a group. But these 2 numbers are left out. Since there is no any third number, that is, there is no any third 3 is there. So therefore, these 2 numbers are left out. Hence, it is not a perfect square. Again, 729. So it is 3 into 3 into 3 into 3 into 3 into 3. That means these 3 numbers forms a group. Again, these 3 numbers forms another group. So therefore, it is a perfect square. Then question number 3. Question number 3, it is given that what is the smallest number by which 675 should be multiplied so that the product is a perfect cube? So we need to find the smallest number by which 675 be multiplied so as to make it a perfect cube. That means 675 is not a perfect cube. So let's see the answer. So we do the prime factorization of 675. If we do the prime factorization of 675, it is 3 into 3 into 3 into 5 into 5 into 5. So that means at the beginning these two 5s are left alone. So if we multiply another one 5 with this, so it will become a perfect square because these two 5s are left out after forming the group, because two 5s are there extra. So these two 5s are left out and this is not forming the group. So in order to make it a group, we must multiply it by 5. So hence to make 675 a perfect cube, we need to multiply it by 5. Then again question number 4. Question number 4, it is given that what is the smallest number by which 2916 should be divided so that the quotient is a perfect cube. That means it is not a perfect cube. So we need to find the number by which this must be divided so as to make a perfect cube. So let's do the prime factorization of this. So prime factorization of this, it becomes 2 into 2, again 3 into 3 into 3, again 3 into 3 into 3. So that means if we can form the group of these three numbers, but this 2 into 2, that means 4 is left out. So this is coming extra. So if we divide this one, so if we cancel this one, then it will form a perfect cube. So hence we need to take out this one. So how we will take out this one? So that is 2 into 2. That means we have to divide this number by 4. If we divide it by 4, this 4 will cancel this 4 and only these two groups will remain. Hence it will become a perfect cube. So hence to make 2916 a perfect cube, we need to divide it by 4. Hence we need to divide it by 4. Now question number 5. Question number 5, it is given, write cubes of 5 natural numbers which are multiples of 3 and verify the following. That cube of a natural number which is a multiple of 3 is a multiple of 27. First we need to find 5 natural numbers, any natural numbers that must be a multiple of 3, and later on we must show that a cube of those natural numbers which are multiple of 3 is also multiple of 27. Now the cube of 5 natural numbers which are multiple of 3 are as follows. So 3 into 2, 6. So therefore 6 is a multiple of 3, since we obtained 6 by multiplying 2 with 3. Again 9 is a multiple of 3, since we obtained 9 by multiplying 3 with 3. Again 12 is also a multiple of 3, since we obtained 12 by multiplying 4 with 3. So here if we do it 6 cube, so we will get 216. This 216 again we can represent as 27 into 8. That means it is a multiple of 27. Similarly this 9 cube is 729, we can represent as 27 into 27. That means this is a multiple of 27. Again 1728 we can represent as 27 into 64. That means this is a multiple of 27. In all the cases we get 27. Similarly, since we need to find 5 such numbers which are multiples of 3, so 3 into 5 is 15. So 15 cube is 3375, which is again expressed as 27 into 125. That means it can be expressed as a multiple of 27. Again 18 cube, 3 into 6 is 18. 18 cube 5832, which can be expressed as a multiple of 27. That is 27 into 216. So therefore 6 cube, 9 cube, 12 cube, 15 cube, 18 cube can be expressed as a multiple of 27s. So hence the cube of a natural number. So these are the natural numbers which are multiples of 3, and the cube of these natural numbers can be expressed as a multiple of 27s. Hence we can write, or we can conclude that the cube of a natural number which is a multiple of 3 is a multiple of 27s. Hence the cube of these natural numbers which are multiple of 3 is a multiple of 27s. So with this we remain. The remaining we'll discuss in the next class. Thank you.